Hey everyone, welcome back to my channel, and this is Harika. So, as a part of our Microsoft Azure AI services series, we have seen a lot of videos till now, right? So, how we can actually use machine learning and the studio, how to create resources, and what are the different services that are available. And in today's video, I'm going to talk about one of the most interesting feature, computer vision. So, why I say this is interesting? Personally, I feel computer vision is not just about image analysis, but it's also about extraction of the data using OCR and also face analysis. So for everything, we use one or other service of computer vision. So before I go ahead and show you what we do in today's labs and what are the features or the capabilities that we're going to explore, I wanted to give you a quick brief or idea about what all the different architectures and the technologies that we use behind the computer vision in order to get these capabilities work for us. So before I do that, let me just show you, as I was always suggesting you to go through this Microsoft Learn link on which is the official documentation and the course that is available for AI 900, which is Azure AI Fundamentals. So for this purpose, you can go to Fundamentals of Computer Vision, and where you can learn about computer vision, face recognition, and also OCR. So our video today talks about computer vision and what is image processing, a bit about it. I'll not go too much in depth where you can understand through documentation, but I will be going through the high level overview of it to give you some understanding of how these models are actually performing, what's happening behind these models. So first of all, when I talk about computer vision, let me go for image processing. So whenever we talk about image, so the first thing that comes into mind, like how this image is being understood by a computer. So basically, images are given in a form of this or the numerical representation in where the pixel values have been provided. So if you see on the screen that we have a pixel images, right? The image is being converted into pixel values, which is 0 and 255. So 0 means it's a black, and 255 means white color. So the numerical representation of this particular image is this. This is how the computer is going to understand how the image is looking like, right? So if you see, this is a gray shade image, but most of it, like in our day-to-day life, we encounter not a grayscale image, but more of a colorful images, right? Where we have a different color combinations like RGB, red, green, and blue, right? So in that case, how the model is actually, how the numerical representation has been provided is like this, right? So for red, we use this, blue and green, we use this. So the resulting image, like how this image is, like if it's only RGB, how we are able to see different types of different colors of images. So for that purpose, we use filters. Okay. So how this filter, so let's say this is one filter, and this is the base image. Okay, so over this base image we will convolve. Okay, we will convolve this whole filter, and that will result in a particular color and the image. So if you see here, we have convolved that into that particular kernel over the base image, and which has resulted in a different image, right? So when we are doing that convolution across the existing images, that will provide a different feature or processed image. So if you see over here, this is the original image, and when the filter is convolved across the image and creating a new array of values, right? So when this is convolved over an image, that provides a feature where is a filtered image that highlights the edges, right? So this process of filtering this, as we are convolving this over an image and getting an filtered image, this process is called as convolutional filtering. Okay, you can remember these terms. Maybe if you're going for a certification, this will be helpful for you. So when we do that convolving over the original image, the processed output filtered image is a convolutional uh, convolutional filtering. Okay, so like this we have different types of filters which will be used for blurring, sharpening, color inversion, and other effects. So this one effect is we are basically using for highlighting the edges of the image. So this only this much is this part is covering only the image processing. But if you observe, computer vision is not only about image processing, right? It's not only about blurring the background or highlighting the edges. It's more about identifying the images, um, and object detection, classifying the images, and all of that, right? Like extracting the tags and captioning the images. There are a lot of other features. So how this is actually performed is something that you have to do. So when you talk about machine learning on the computer vision, so there's a particular architecture that computer vision actually uses is convolutional neural network. So this particular architecture helps in order to extract the features, like extract the features from the image, and based on that features we fed it to the deep learning model. So if I show you this particular image, we use the convolutional neural network and we extract the key features of this, and which will be fed into the deep learning networks. So if you have seen the previous videos, I spoke about regression and all of that, right? So in which also we were using the um, in few classification models we were using the neural network, deep learning network, right? So in that case also we will first it's kind of working on the same procedure, where we first assign the random weights, and based on the value that is predicted and the actual label, we kind of make a judgment whether the loss is more or high, based on which we adjust the weight and we fine tune the model until the output. The If you see here, we have given all these different types of fruits as input, right? So if you see, the object detection has been labeled 0 with apple, 1 with banana, and 2 with orange, right? So we kind of check if the label prediction is accurate. Based on that, we kind of train the model until it predicts the accurate results. So it uses convolutional neural networks initially in order to extract the features, and fed to the deep learning model, where we make the predictions, where we do the trainings until the predictions are accurate. So this is a model that we use, and that is a base of the computer vision, like where we use convolutional neural network. But there is also something that we can work on computer vision, right? So for that purpose, there's a concept of transformers which we use in the NLP that I talk about in the next videos. So where the transformers works on a concept of they process actually a huge amount of data, and the using the language tokens represents each word or the token as a vendor. Okay, sorry, as a vector based embeddings. So basically this transformers use large amount of data in order to make the predictions. So the combination of this transformers into our computer vision, like enhancing this to the image analysis, the like the transformers we were initially used only for NLP, like only for the language based or the text based data. But applying this to the image data, so where we have come to a concept of multimodal models. So if you see over here in this, so initially what happens with the transformer is, if you give some data to the transformers, whatever the text that you provide, it will convert into a vector based embedding, right? That means it's like a three-dimensional or a array. Okay, so it will kind of place this particular value on on this space, where it will have all the images, all the words which are having the similar context into together, and which are not close by will be placed somewhere far to the context, right? So if you see here, fruit, apple, orange, banana, all this belongs to the similar context. So we have placed them all together. But if you see the skateboard, it's not close to these, so it has placed somewhere else in the vector, right? So we use this transformer concept in order to place them on a vector, and all the images that have the similar context will be placed close by, and that has a far different context will be placed somewhere far, right? So this is a concept of the transformers. When we apply that to the images as well, to the data of the images as well, then you can see something like this, where a multimodal model has come into existence. It uses the both language encoder and the image encoder, and where we fed this model with a large amount of captioned images, where the image features will be fetched using image encoder and the captions using language encoder. So we place all of them into these spaces, which results in a accurate predictions. And if you see over here, this is a foundation model, which is also called as Florence model. Okay, so this is a Florence model on top of which we utilize it for classification, object detection, captioning, and tagging, right? So this is the whole story behind the computer vision, where all these capabilities has come into picture. So now what I'm going to do is, before I go into the studio and show you how this actually works, I would also recommend you please go through this complete documentation. This will give you enough idea and understanding on what are these different capabilities are and how you can utilize it further. So yes, as I told you, for every capability to work or utilize, you have to create a resource. So I have already create an Azure AI resource. So you can also utilize either computer vision or Azure AI resource. So I'm using Azure AI. So I have created the resource already. I have shown you the step-by-step way how you can do it in the previous video. If you want, please go back to that video and check how you can create a resource. And now I'm going to show you what we can check in the image analysis. And as I mentioned you, computer vision also have capabilities of space and optical character recognition, which we will see in the next videos, because I wanted to talk about a little bit on what are the things that they use behind the model in order to get these features or capabilities work. So I'm going to image analysis first, where I am going to show you um let's say object detection. Okay, so let's go for object detection. So I am having my Azure AI model already linked with it, so let's go for this. So if you see in this, I'm having two things, right? So the first one is the person, and this is a skateboard. And if you see, it has returned the output with the bounding box and along with the confidence score, right? So these are the objects that are there: person, and then laptop is here, laptop, right? This is object detection. The object has been detected using this model. And then if you see, there is also something called as common tags. That means extracting the tags. So if you see, there are a lot of tags: indoor, table, coffee table, human face, sitting, couch. These are the common tags that we have on this particular image. So if you see, go over here. So we have text, we have wheel, outdoor, bicycle, bike, land, grass, and all of the different tags that we have. And next, if you go, captions, adding captions to the image. So if you see, man holding a surfboard on a rock, a group of cows gazing in a field. So these are the different captions. And let's also explore. We have also seen some other, these are the, on top of the Florence model, we can see object detection, capture, captioning, tagging, and all of that. But before to that, excuse me. So before to that, in image processing, we have also seen blurring, removing the caption, highlighting the edges, and all of that, right? So let's see that one as well. Removing backgrounds from the image. So I have, it's already linked. So yeah, this background has been removed, right? So let's take this. So we can see here also the background has been removed. So like that, we can use this model as well. And what else we can check? Recognize product on shelves, add dense captions, that means more captions, extract common tags we have seen. Okay, cropped images also. Create some cropped images. So let's see this. So this has been cropped. If you just adjust, right? If you want to crop more. So like this, you can as well do the cropping, right? So these are the different capabilities that we have in the computer vision. You can just give a try over here on the image analysis. And most importantly, you have to understand what are the architecture and the models that are used behind in order to get this capabilities work. So that's a main important thing where I wanted to talk a little bit about it before we come across over here as well. So you can just explore Microsoft Learn platform for AI 900 and the computer vision. So that will give you very much depth understanding of all of this. Thank you so much for watching, and I'll come up with face as well as OCR in the next video. If you like the content, please do consider subscribing to my channel. I'll see you in the next video. Till then, bye.